Today I'll be talking about Nestjs, and I'll actually be discussing all the concepts of Nestjs. So I'll start with the official website of Nest, and here you will see that let's go to the introduction page. Um, it says that Nestjs is a framework for building scalable Node.js server-side applications, which is saying that you can build backend services using Node.js. I mean, using Nest.js, and Nest.js is kind of a wrapper because see, Node.js is also a server. Um, so yeah, Nest.js is basically a wrapper on top of the server implementations that can be written in various Node.js frameworks, for example, Express or Fastify. Now, the other thing that Nest.js says is that you know you can write HTTP servers and on frameworks like Express or Fastify, and there can be trade-offs when you do that. So, for example, Fastify in general is at least 20% faster than Express, and but there are a lot of plugins that directly support Express and not Fastify. And instead of the programmer thinking about whether he should be using Fastify or Express, Nest.js is telling us that if you just follow the guidelines and the design choices that Nest has laid out for you, then you should be able to switch between either Express or Fastify at any given at a later stage. So Nest takes out all of those fear that you would have while starting a project. You know, that's one advantage of Nest.js. The another advantage of Nest.js is that if you have used something like Angular, or if you have used Spring Boot, Nest.js is going to seem very familiar because it basically uses the same concepts, the same principles. It uses decorator pattern and so on. Now, without talking a lot about Nest.js, let's just get started. Let's just write a small application and show you how all of it works. So I'm just going to copy npmi-g nest CLI. This is going to install the Nest CLI, which we can then use to create a Nest.js application. So yes, after that we will once Nest CLI is installed, we can use Nest CLI commands to create a new project. Now, I don't want to create a new folder with a project name. My project name is actually Nestjs. So what I will do is I will do nest new and a dot, which means I want to create the Nest project in the current working directory. So it is going to create the Nest project. It is going to ask you a couple of questions. What package manager do you want to use? I use npm. You can use yarn or pnpn. It's up to you. There is another way of installing Nest.js, which is by cloning this repository. I'm not really going to do that. It's much easier if you can just use Nest CLI to do it. And if you were doing it manually, then you would have to install Nest Core, Nest Common, Rx, and reflect metadata. For us, it's not a problem because if you go to package.json and if you look inside dependencies, the 3 dependencies mentioned here are actually already installed. So we don't have to do that. Let's see if npm install was run for us. Yeah, so we have node modules. We don't have to run npm install again. What else do we have? Okay, let's go back to package.json. There are a couple of scripts that Nestjs created for us. One is the build script, which is going to transpile our TypeScript app into JavaScript. And then there is another one, a format script. Then there is a start script. Then there is a start dev, which is going to start Nestjs in watch mode, which means you will have access to a hot reloading. Anytime you make a change, Nest will automatically start the application. There is a debug script in case there is something that you're not able to figure out why there is an error or where something is breaking or what's the request body. You can use a start script and add some breakpoints. I'll show that to you in the later tutorial. Start prod, and there are a couple of those. There are some test scripts and so on. Okay, Let's look into um, the core fundamentals of Nest. So if you look inside a Nest repository, for example, if you expand this source repository, you will see there are a couple of files. One file in particular is main.js, and this is where your app is bootstrapped. So if you look here in start prod, you will see that it is trying to start a file called main.js, which is main.ts. When you transpile it, it becomes main.js, and then you start it from there. Now it's trying to create a new Nest application, and it passes the app module inside and starts the application at 3000. So let me do that. Let's do npm run start dev. Now this is going to enable hot reloading also. Now let's go to localhost 3000 and see what we have. Localhost 3000. We have hello world. Okay, how is that working? When we create Nest application, we pass it the app module. App module is where all the root level dependencies are registered. For example, here we are defining that the controller is called app controller, the service is app service. So what's a controller? Okay. Whenever the browser makes a request, that request has to be handled by Nest application. And the way Nest application handles it is it will redirect this request to these controllers. And wherever there is a matching route, that function will be called. So here the matching route is actually nothing, it's forward slash. So app module forwards this request to app controller. App controller doesn't have anything here in controller and also doesn't have any route here. So get hello function is called. To clarify, let's say that we wanted to handle a route called API and hello. Let's say we had this route to handle. There are two ways to handle it. One is API/hello, and it wants me to use single quotes. Right now you still see hello world. The other one is gone now because there is no root level routing here. So API/hello handles this route. So app module redirects it to app controller. There is no route defined here, so it goes to API hello route. Other way of handling this would be to add a root level route. So any request that starts with API will now be handled by app controller, and then this becomes a sub route. So the result is same, but let's say we had add get and a different route here, get, and then you could return, right? Now if I go to it gives you this. So any request coming that starts with API, like this request starts with an API, it goes to app controller now, and then inside app controller we are looking for a sub route which contains this. Cool, everything is good this far. Let's discuss let's see what else Nest has for us. So just to summarize, main.ts is where the application gets bootstrapped. App module is the root module, and I'll tell you why I'm calling it the root module. That is because this is the only module that's being loaded in main.ts. There can be other modules as well, but we are not going to load those modules here when we bootstrap the application. We will load those modules inside the imports section of app module. So it's like app module is the root from which there are multiple other modules that are connected to the trunk of it. If you think of it as a tree, then app module is the root of that tree, and then everything else is attached to it. Now app controller spec is the test file for app controller, for testing app controller.ts. Now app controller is the entry point through which all the requests, not all the requests, but it's just one controller, right? Okay. Now we already talked what controllers are. So there is a browser, it makes HTTP call, it goes to one of the controllers, and whichever controller has the correct mapping for that route handles that request, right? We talked about routing, so that's done. Let's move on to providers. Okay, there is something else called a request object. Now, before discussing request object, let's talk about something else. So if you know, if you have learned REST APIs, you know that there is something called a path parameter, which means that if I had to, if let's say this, instead of being Hola, if this was the ID of some user whose record we wanted to get back, right? So this is then the user ID of that user. How do we handle that? We go to app controller, and here let's define this as user ID. So anything that comes after API now becomes a user ID, right? So the way to capture a path parameter is you define it here. So this the string inside path parameter should be the same as the string that you defined for path parameter on get request, and we define the type. So user ID will be of the type string, and then let's return a template string. The user ID captured was user ID, and if I refresh now, it says the user ID captured was Hola, but could be something like that. It's not a good thing. The user ID captured was ABCD, which is fine, and okay, that's a path parameter. There are other ways to pass information in a get request. The other one is actually a query parameter, and the way you write that is, okay, why do we have a query parameter? Let's say to the same route you want to pass different information based on the context, right? So the way you do it is you write query, this could be anything basically, and this is the query. Okay, now to capture it, you can use another decorator called query, and let's see, I'm not sure how to capture this. And also the type of query. Let's see. Now it says it cannot find it. Let's see. Query was undefined. Let's see. Query was query 1, I think. Yes. So it has to match what is on this. So question mark query 1 equal to this. So this query 1 is going to be the same as the string that you define inside the query decorator. So that's another one. We can also capture the entire request and see what's inside of that. So let's see what does a request look like. It's called REQ, and it comes from Nest common. So let's import it from Nestjs common. And the interface, I think, is REQ, and let's see what's inside a request. I think you have to pass the decorator. Let's see. Request is request. What's wrong? That's a pretty problem. Okay. Now this request has to be imported from Express. So let's do that. And if you refresh, you will see what a request object really looks like. So there are a lot of things actually inside of a request. There are headers, and these are the headers being passed from the browser. And there is a whole lot of information here which I don't think is required for us right now. So I'm going to skip this for now. But a request will have headers, a request will have body. So let me just show you what a request, okay, let's print request dot headers and request dot body. And these two things are null actually right now. So these are all the headers that the browser sent us, and this is the body. This will come handy when we are dealing with post requests. Alright. So those are the other two things that we had. Now a route can also have wildcards. We don't usually prefer using them, but you can match a lot of routes with wildcards. Now with every HTTP request, you can actually return a response code. So if I open the terminal right now and we look for this request, the status is 304, which is actually not the correct status. What is status code 304? Don't know. Okay, but if you wanted to, you could return a status code which corresponds to the status type. So for example, 200 is okay. So we want to send a okay response code if there was no error. Let's do that. And if you do organize import, it will automatically remove any unused import. It's still 304. That's weird. We'll have to look into that. Anyways, let's move forward. You can have errors, you can have redirect. So basically, if there is a path that no longer exists and you want the front end to automatically redirect to a different path, you can use a redirect header for that. So we already discussed about path parameters, and these actually we should be handling these from Nginx, so which is if you want to check whether the request that's incoming, the host of that request is this or not, we don't actually use these. Alright. Let's also start working on some post requests, or maybe we'll take that up in a different tutorial.